What up, dudes? Can you hear my voice? Yes. No, yes. Awesome. Can you see my computer screen? Not my face, but my computer screen. All right. And we're recording. Good. All right, so check this out. Here's what I'm going to do today. My plan is I'm going to just kind of start off with kind of a talk story, making sure that you folks feel comfortable with what we're diving into, making sure that it's not like cray-cray stuff. Got it? And then what I'm going to do is, as I slowly go through this stuff, I'm going to try to see if I can teach you some kind of profound equation that you've seen before, but maybe have never known where it comes from. All right? And then the last thing I'm going to do with you folks is I'm going to go over your final exam, which I already put it up for you. So you have an opportunity to start your final exam like a week and a half before it's actually due. And literally that's what your final exam is going to be. I'll explain it all to you. I posted it up on Friday, but I didn't have a chance to explain it because I recorded 2 videos and both of them crashed. And I was so pissed by the end of it. I was just like,
too bad.
Too bad. You guys aren't getting a video. You're going to get a video on Monday. Deal with it. All right. All right. Well, okay, fine. I'll answer questions about the midterm. I just said I was going to finish that at the end of the day. But, Sophia, to answer your question, the test is basically 2 parts. It's a written part, which is kind of like which is kind of the same problems that you folks have been used to that I've been giving you, and that's all on lines and linear stuff. And I gave you a practice exam to do that. So that practice exam is really straightforward. You just go through it and do it, and I promise you that the final exam, that part will be almost very similar. Very, very similar. I can't say identical, but very similar to those. I'm not going to try to throw any curveballs at you or anything. The second part is more of a project-based kind of cool thing where it's not really like this straightforward math exam. It's kind of this creative way of having you understand math. And then that one you have to make like a presentation about. And that one takes like, I'll give you a week and a half to do it. All right? So that way, and actually, Genesis, the reason why I'm doing this is so that you don't get so nervous. Because many students freak out with having to take a timed test and everything. And so I figured, I'm going to do math class at least for quarter 1. I'm going to do it in a way where you have as much time as you need. Sound fair? So the written part, the computer-based, the problem ones, your traditional ones, those are only covering lines and functions. I can't say just functions because functions include parabolas as well, but yes, linear functions, you're correct. Now, Genesis, so don't be so nervous because the whole point of me doing this is so that way you don't get as crazy nervous. That's not necessarily going to be the case next quarter because eventually you're going to need to be able to take tests that are time tests, and I need to get you guys on the ball with those. And my plan is to make you do a lot of those. So anyway, all right. Are you going to set homework for... Oh, you know what? I was told you that I was going to do homework for 4.110, and I don't know if we have the time for that. To be honest with you, I didn't even put up the answers, I didn't even finish writing out the problems for homework 5, which is the chapter we're covering today. But that's fine. That just means you don't have homework due yet. You'll have at least 2 or 3 assignments due this week on Chapter 5, and we'll get into it. And it's not going to be so bad, all right? The point that I'm trying to do today is just so that way you can approach these things without freaking out, okay? All right. Let's kind of recap everything we've covered on parabolas. We've got somebody new here, and this person has never really seen how we run class, so I figured, why don't we just kind of recap things so that way we can kind of wade in at the shallow end of the pool and then slowly get deeper today. All right, cool. If I had a function f of x, f of x is equal to, I don't know, I'm going to make one up, x squared plus, let's see, 4x plus 5. Yeah, x squared plus 4x plus 5. Got it? And I ask you to graph that. Okay? There are things we can pull out of that already. First of all, is this a happy or sad parabola?
Happy.
It's a happy parabola. The reason being, anyone?
No,
Because it is positive.
Because we look at the number in front of the x squared term. Since there's no number, we assume that that number is 1. All right? And since that number 1 is positive, we know that this parabola opens upwards. It's like a happy face. Is this familiar with you?
Mm-hmm.
All right, good. Oh, by the way, don't feel like I'm picking on you today. I picked on her 2 weeks ago. And the reason why is just because I'm probably going to be turning a lot to you, just because I want to make sure that we're catching you up.
Okay.
Sound good?
Yeah.
All right. So it's a positive 1x. Where is the where's the y-intercept? At 5. Very good.
Oh, that is the y.
Because when you set the y-intercept, when you do the y-intercept, you set x equal to 0, right? If x were 0 here, then that's 0 squared, still 0. X is 0 for the second part, 4 times 0, still 0. So the only thing that survives is the 5, and so basically you know that that's the y-intercept. Don't think of this as a parabola being pushed up by 5. This is a parabola that has a y-intercept of 5. Lucas, what you're thinking about is you're thinking about the parabola in vertex form. All right? All right. So we know that the y-intercept is 5. We know that it's a happy parabola. In order to find more information, what we would need to do is factor this thing, if we can. And I think we can. X, oh wait, oops, no, I had these switched, I'm sorry. See, that's the problem when making up stuff in your head, you accidentally put the wrong stuff. There we go, 5 and a 4. I apologize. That would mean, what would I need to change? I need to change my x-intercept to be at 4. I'm just going to make a big blob to say, it's around there. That's ugly. Never mind. Here, let me just redraw this a little. There we go. Redraw this a little bit. Make this a 4. Sound good to you? Okay. I'm sorry. I apologize. I screwed up the problem. I'm trying to think of all these variables in my head. Okay. So when we factor this, we say, all right, well, plus and a plus. What numbers can go here? And the candidates would be 1 and 4 or 2 and 2,
Oh, yeah.
as long as they're two numbers that multiply out to be 4. The ones we're going to choose, though, on this hand is going to be a 1 and a 4, because those add up to be 5. We wouldn't choose the 2 and the 2 unless this number were 4. Does that make sense? Okay, good. So I'm going to go with a 4 and a 1 here. This miraculously tells me my x-intercepts. My x-intercepts in this case would be where?
4 and...
Nope, not 4 and 1. Negative 4 and negative 1. It kind of tends to be the opposite of what we see in there. And you guys remember this, right? So negative 1 and negative 4 right here and right here. I could draw the parabola already if I wanted to. Where would, I mean, without doing any real calculations, where would you say the vertex, the x-coordinate of the vertex is located?
In between negative, one of them is going to be in between negative 2 and 3. Is that what that is?
No, that's negative 1 and 4.
Oh yeah, in between negative 1 and 4.
2.5. Actually, Cameron means negative 2.5.
Mm.
Exactly. So somewhere along here, because that's the point that's in between those two x-intercepts. And I'm not really going to calculate it out, but it's going to look something like this. Sound good? All right, cool. Now, this is standard form. This is factored form. They are both describing the same parabola, they just look a little bit different. There's another form called vertex form, and I'll show you where that's useful. Let's kind of, I'm just going to make up another problem. How's this? 1x squared plus, what would be a problem that doesn't work so well nicely? Yeah, let's go with 5x plus 6. Let's just try that one out for size, all right? Okay. We want to graph this thing. We know it's a happy parabola. We know the x-intercept is 6. We should be good, right? The problem that we're going to run into here is x and x. There's going to be a plus and a plus. And what numbers should go here? What numbers, what are candidates that we can use? 3 and 2? Oh, man. I can't believe it. I accidentally chose a problem that you can do. All right, how's about this one? Screwed it up again. Let's go with an 8. That will mess with your head. All right. What are the chances of me accidentally choosing one that you can solve? Usually, if I randomly choose numbers, you wouldn't be able to factor it. All right, all right. So, no. You guys are saying 4 and 2. No, you need to give me 2 numbers that multiply out to be 6. If 4 and 2 do not multiply to be 6.
3 and 2.
3 and 2, good.
1 and 6.
1 and 6, okay. 3 and 2 and 1 and 6 are the only candidates that I have that can go into these numbers. However, there's a problem. 3 and 2 add up to 5. If you ask me to make -1, I could use 3 and 2 somehow.
Mm-hmm.
If you ask me to make +1, I can use 3 and 2. If you ask me to make 5, I could use 3 and 2. If you ask me to make -5, I can use 3 and 2. What about 6 and 1? I can only really make 7 or 5, but I can't really make 8. There's nothing I can do to make 8. Do you see?
Mm-hmm.
So the problem that we have here, my friends, excuse me, I'm kind of sick. All right, so the problem that we have here is this cannot be factored. So we turn to this really powerful technique that I taught you guys last week called completing the square. And let's just go through that really quickly so that way it's a little bit of review for you. All right? What we did was we put, well, first thing we did was we made sure the A term was 1. This step came up only when there was a number out in front here. And remember, we kind of temporarily factored it out. Were you here for that lecture?
I probably was, but I don't think I was in my good fun paying attention.
No, that's fine. That's fine. I'll show you folks where that comes from, but that came when we were temporarily factoring it out because we don't like completing the square unless that number is 1. Unless the A term, which is the thing in front of the x squared, is equal to 1. We cool? Mm-hmm. All right. Then we did this kind of random thing. And if you vaguely remember it, then just let me know if this is kind of familiar to you, because you can go back and watch the videos. But we took the B term, divided it by 2, and squared it, and squared. Okay? Then we took that number, whatever we got there, and added it, and subtracted it, to our equation. That's a mouthful. Let me show you what that step is. It's actually pretty easy. Okay? Sophia will talk about why we subtracted it. Okay. So what I'm going to do, actually I might have missed a step, but it's not really a real step, but you kind of put a big space. So let's do this. X squared plus 8x plus 6. Any complaints so far? All I did was I made a big space because I'm going to do something funky there. Got it? Mm-hmm. Now, the B term is the thing that has the x next to it. So it's the 8 because there's the A, B, and C. So the B is the 8. We cool? The B term, yes, Sophia, the point of us doing this is so we can put this into our vertex form. Yes, exactly. We're talking about this right now. So the B term is the 8. We take that and we divide that sucker by 2. That becomes 8 divided by 2. Anybody?
4.
4. Good. Then we square that.
2.
No, square it. 16.
Oh,
Awesome.
16.
So we're adding 16 to one side. Because we take that number, we add it to our equation. And I also said we subtract it from our equation at the same time. And Lucas is kind of answering Sophia's question. Sophia asked earlier, wait, why are we subtracting 16 at the same time as adding 16? And my answer is this. We had a discussion on this, but here's what my answer is. We don't want to change this equation. We just kind of want to play with it a little bit. So if we just add 16, that would be changing the equation. But if we added 0, that wouldn't be doing anything to the equation. I can add 0 all day long.
Mm-hmm.
So adding 16 and subtracting 16 is equivalent to adding 0. I didn't change nothing. You can't fault me for nothing. You see what I'm saying?
Mm-hmm.
All right. Now, what happens in this completing the square magic is that miraculously, these first 3 terms are a perfect square. So, the first 3 terms are a perfect square. Which says I can factor that thing nicely. Can you guys factor it in your head? Or not in your heads, but can you factor it? X, X, plus, and plus. What numbers should go there? What numbers multiply out to be 16? 4 and 4. There we go. In fact, since it's x plus 4, would it be all right with you if I just wrote x plus 4 squared? It's x plus 4 times x plus 4, so it's just x plus 4 squared. Does that make sense?
Yeah.
Then I still got to deal with the negative 16 and the plus 6, so this would be minus 10. Because negative 16 plus 6, that would be this guy over here, is negative 10. I didn't really change anything. I just made it look a little bit different. And if you FOIL this thing out, you'll realize that it's the same as the standard form that we had above. But now I'm able to graph this thing. Now I'm able to take this thing and know exactly how this parabola moves around. What does the negative 10 do to this particular parabola?
Is it the y-intercept?
No, it pulls that whole parabola down by 10. What does the 4 do to this parabola?
So y-intercept, so it brings it to...
No. Sophia's got it.
Moves it to the left.
Remember, the thing inside the parentheses moves it
yeah.
left and right. And remember, this is the funky one where it does the opposite of what you think it would do. That plus 4, it actually moves it to the left 4. So, my parabola, if I were to graph this very ugly version, I would say down 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and to the left 4. Somewhere around here. Happy face parabola, around there. Sound good? Now let me think. If we wanted to find this is f of x is equal to this. If we wanted to find the x-intercepts, what should we do? Whenever we find the x-intercepts, we set what equal to 0?
Y.
We set the y equal to 0. And in this case, it's noted as f of x, but it's the same as y. All right? So in order to solve for x, this is actually pretty simple. I'm just going to move the 10 over to the other side. Take the square root of both sides. Remember to not forget that plus or minus. I don't even need those parentheses anymore. I'm going to drop them. Alright. I'm going to subtract 4 from both sides, so I have x is equal to negative 4 plus or minus the square root of 10. Does anyone know what the square root of 10 is? Use a calculator. I mean, I don't expect you to know it off the top of your head. I would say that it has to be like 3 point something. Oh, there we go. 3.162. Awesome. So what I'm dealing with is negative 4 plus 3.162 or negative 4 minus 3.162. So I'm looking at what's negative 4 plus 3.162? Use a calculator, please.
I think I missed a step. I missed something.
Yeah, that's right. No, wait, no. Negative, am I tripping out here? Negative 4. What's negative 4? All right, what's 4 minus 3.162? It's got to be like 0.9
something.
8, right?
0.8 something, yeah.
Yeah, yeah. This is that answer. When it's negative 4 plus 3.162, the answer is negative 0.838. And the other one is negative 7.162. So those are my two intercepts. Oh, what happened?
Did it turn off?
Did my screen share die? All right, let me try it again. Please don't fail me now. I actually want to finish class today. Man, I don't have a whole lot of time. I got like 15 more minutes. That's it. Which isn't a lot of time in my case. I always talk story and that kind of stuff. So tech problems are particularly annoying. All right, there we go. Can you guys see that? Okay, all right, good. Now, the reason why we weren't able to factor, I'm just letting you know, the reason why we weren't able to factor that in the first place is because this didn't come out to a nice number. If we had something like the square root of 4, or the square root of 9, or the square root of 16, we would be able to deal with that really well, and actually you would have been able to go back and factor it using the old school techniques. But the problem is we had the square root of 10, which comes out to be an extremely ugly number. Apparently it's 3.162. That's why you couldn't factor it. The beauty of this is, though, is that with completing the square, you can factor anything. Or, well, you can get an answer for anything. Does that make sense? Mm-hmm. See, factoring only really works. See, this first technique that we showed you at the beginning, that game only really works when the numbers come out nice. When these x-intercepts land nicely on good numbers that we can see. You know, solid integers, that's what we call them. When they don't land on solid integers, like for example, negative 0.838 and negative 7.162, that's when you need the power of completing the square. The way I look at it is it's like the difference between a bazooka and a fly swatter. If I had a fly inside of my office, okay, I could use a fly swatter. Boom, nice and clean. Or I could use a bazooka. The bazooka is a pain in the butt to set up. And it also does a lot of damage. But it will kill the fly, I guarantee you. Mm-hmm. You know what I mean? Mm-hmm. So if you're up against a problem, you can whip out complete the square, and that always guarantees will give you an answer. It will always work. It's a pain in the butt to do. It's a long process. You just saw the process, but you can do it. It will work. I guarantee it. Or if you could factor it, use the fly swatter. Use the nice, quick, elegant technique. Factor it. Boom, done. They'll give you the same kind of results. Anyway, that's my bazooka story. All right. On to the quadratic equation, which is this nice, elegant formula. First, I need to ask, is everyone cool with the steps of completing the square?
Mm-hmm.
All right. Now, what I'm going to do in the next, hopefully, 10 minutes is I'm going to show you a formula that seems like magic. And most of you are going to be looking at this and freaking out because you're going to be like, oh my gosh, is this what our homework is like? And the answer is no, it's nothing like this. The thing is, you know my pet peeve. My pet peeve is I can't stand it when teachers pull equations out of their pocket and throw it up on the board and say, memorize this for the rest of your life. I cannot stand it. I need to have teachers explain to me where this comes from. So this is why I spend so much time talking about the complete the square process with you. Because the quadratic equation, believe it or not, comes exactly from complete the square. That's all it comes from. Got it? So, watch it. Watch what I'm doing. Hang in there. At the end, we're going to get this ugly equation, which isn't really that bad in the end, and I'll show you how to use it. And then on Wednesday, we're just going to talk about it some more. All right? All right. So, I'm going to start off with my very standard form. ax squared plus bx plus c. I'm going to set that equal to 0. Let's see. Should I set it equal to 0? I'm trying to think. I'm going to set that equal to f of x, or y. I'm going to set that equal to y. All right? Now, what I'm going to do is, the first step we do is we want to complete the square on this sucker. The first step we want to do is we don't like completing the square on things that have an a in front of them. We like completing the square on things that have a 1 in front of them. So I'm going to divide everything by a. Divide this by a, divide that by a, divide that by a, and that by a. So I have x squared plus b over a times x plus c over a equals y over a. I also did kind of a mini step in there too. I put this weird space in between here. And we know what's going to go there, right? We're going to add something and subtract something within that space, so, you know. All right. What I do is I take the middle term, that b term, and in this case our b term is b over a, so it's a little bit confusing at this point, but I take this thing right here, the thing in front of the x, I divide it by 2, and I square it. So what is b over a divided by 2? Well, it's really easy. It's b over a, b over 2a, right? That's what it is. What's b over a divided by 2? It's b over 2a.
Why is it not 2b over a?
Well, because that would be multiplying b over a times 2.
Oh, okay.
The 2 goes in the denominator because you're dividing the 2.
Mm-hmm.
There we go. Okay. And I square it, right? So then I would have to square this and make it b squared over 4a squared. B squared over 4a squared. Got it? All right. But then again, what's the rule? You can't just add something. I need to subtract b squared over 4a squared.
Parents are downstairs.
Oh, okay.
Sound cool? You can go if you need to. All right. All right. So, no, wait. Let me answer the old topics before, and I want to cover the quadratic equation. I want you. This is like an important derivation for me because it's exactly aligned with my pet peeve. I don't like people. It's saying use this for the rest of your life. I'm not going to explain to you where it comes from. You just use it. All right, you ready? These first 3 terms factor down into this. That's the first 3 terms. And that's nothing new, right? We've seen that happen a couple times. Are we cool with that? All right. So what I have underlined is really that thing that we have to square out. And if you don't believe me, square it out and you'll see that it's the same exact thing. Okay? I still got to deal with this stuff on the end. So let's go minus b squared over 4a squared plus c over a equals y over a. And again, don't worry, your homework is not like this. I'm just trying to do the derivation for you. Your homework is much easier than this. Anyone like dealing with fractions? I hate dealing with fractions.
I'd rather do the fractions than.
Why don't we just multiply everything by a to at least get rid of this fraction over here? Sound good? So a times x plus b over 2a squared minus b squared over 4a plus c equals y. The a that went below the c got multiplied out. The reason why it's not an a squared is because one of those a's got killed. Are we cool? In fact, actually, there's one more step that I'm going to do. It's kind of like a mini step. But I'm going to multiply this one. Instead of just having a c, I'm going to put 4ac over 4a. I'll tell you why. And it's obvious, really. Or it will be obvious. The reason being is because I want to combine these two numbers right here. And in order to add two fractions, I need to have the denominators be the same. Really, if you cancel out the 4a and the 4a, this still becomes c. And so there's nothing really different that I did. I'm just trying to make the denominators the same so I could add them. Anyone afraid of that? No. All right, cool. So a times x plus b over 2a squared. Let's just do it like this. Let's go with, all right, equals y plus b squared minus 4ac all over 4a. Did I freak anybody out there? What I did was I just moved this thing over to this side and this one over to that side. It's nothing really magic.
So if you move something to the other side of the equal sign,
it just becomes a different sign. Yeah. So if it's subtract b squared over 4a, you move it to the other side, it's plus b squared over 4a. Okay. And then all I did was I put it over a common denominator, which my common denominator happened to be 4a. Are we cool? No trickery. Just straightforward, whatever. All right. We wanted to find the x-intercept, so what we're going to do is we're going to set y equal to 0. Nothing funky there. Right? We want to find x-intercepts, you set y equal to 0. We want to find y-intercept, you set x equal to 0. This time we're finding x-intercepts. We cool? So that y that you see over there, that's 0. Let's deal with that. A times x plus b over 2a squared equals y. Oh, wait. 0. I don't need it anymore. B squared minus 4ac all over 4a. Okay. I'm going to square root this thing because I'm going to get x all by itself. I'm going to square root this thing, but before I do, I'm going to move that a over. X plus b over 2a equals b squared minus 4ac all over 4a squared. I forgot to add the square here. Are we cool? All right. Now I'm going to square root both sides. Square root both sides. And remember, kids, when square rooting both sides, don't forget to add the plus or the minus. You guys remember that part? The plus or minus?
Oh, yeah.
Nothing magic here, just, straightforward. Don't forget. Just reminding you. So on the left side, you have x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over, since I have the plus or minus in the numerator, that's all I really need. On the bottom, I'm going to take the square root of 4a squared. So that's just 2a. Do you guys see that? The square root of 4a squared The square root of 4 is 2, and then the square root of a squared is a. That's it. All right, last step. I'm almost home free. I need to get the x all by itself. What should I do with the plus b over 2a?
Subtract it.
Subtract it. There we go. And it also has a common denominator with the right-hand side, so I can just take that whole thing and put it over one denominator. Sound good? So I have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Nothing magic here. Just straightforward math. All we literally did was we did the exact steps that we did up here with just a little bit more complicated things. Got it? This, my friends, is the quadratic formula. It's a quadratic equation.
What an equation.
I know, it's amazing. All right. Let me tell you the story about it real quick. You ready? There was this boy. Okay? Let's see if I can make some pictures. There was this boy that's making him a negative boy. There we go. There's this negative boy. There we go. That's a good negative boy. And he was unsure about going to a radical party. I better be careful when I'm looking up images of radical parties.
Yeah.
Look, they gave me images of like a radical political party. Okay. No, I meant like a radical. Alright, fine. Maybe I'll put radical college party.
That's a dangerous Google search.
That is a dangerous Google search. Still more politics. Anyway, radical party. It was radical. You guys can imagine it. Alright. He was unsure about going to a radical party. And so the boy, he decided to go to this radical party. And this boy was kind of a square. What does that mean in your kid nowadays lingo? If someone calls you a square.
Doesn't mean you're boring.
Does that mean you're boring? I don't know.
I don't know.
I know what it means back when I was back in the 1990s.
I'm guessing what it meant back in the 1990s.
Okay, all right. So you're boring. You're not fun to hang out with.
Mm-hmm.
Because he was not fun to hang out with, he missed out on talking and hanging out with 4 awesome chicks. He was at a radical party. There were girls there, but he couldn't hang out with them. There were 4 of them. They were awesome, and they were chicks. But he couldn't hang out with them because he was a square. Got it? This whole party was over at 2 in the morning, 2 a.m. Okay. Ikasia, how's your memory? Not that good?
Decent. It's decent.
Okay, tell me the story.
Okay, there was a negative boy.
Negative boy.
And he heard there was a radical party.
Radical. It was radical, dude.
There were 4. He was a square. He was
Okay.
a square.
All right.
So he couldn't hang out with the 4
Awesome chicks. There we go.
Is it over? Is the story over?
Well, the party was over at...
The party was over at 2 a.m.
2 a.m. There's only one piece that you missed. And the important piece that you missed was he was asked to go, but before he went, he was like, unsure.
Oh, he was unsure.
He was unsure about going to a radical party. You got the story.
Oh, that's a good story.
Okay, good. Check this out. Ready? The boy was negative, right?
Mm-hmm.
Unsure. I'm going to say unsure means plus and minus. Radical is actually a name for the square root. It means radical. You take the radical of something, you're taking the square root of something. What was the boy? When he went to the party?
Oh, he was a square.
He was a square, right? And so he missed out on talking to who?
4 awesome chicks. Oh, I
4
get it.
awesome chicks.
That's
The whole
lame,
party was over at
2 a.m.
2 a.m. 2a.
2a.
There you go. You have now memorized the quadratic equation. There's this lame boy who was unsure about a radical party. He was kind of a square. Missed out on talking to 4 awesome chicks. Party was over at 2 a.m. That's what happens when you're square. All right. There's a song about it, I'm sure. I'm sure there's like cakes made in this honor and whatever. This is an important equation. You're absolutely right. There are things about it. This is one way that I memorized it. And I thought it was a funny story.
That is a funny story.
Yeah. See, you were able to get it like right off the bat.
I like it.
All right. Anyway, I got to end class because I got to start chemistry class at 2:15. I apologize. Dang.
Yeah, that was like 3 seconds.
No. You know what the junk part is I need to cover what you call it with you, or with I need to talk about your final exam. It's important that I talk about your final exam. All right, I'll tell you what. I'll record a video for you and make sure it goes through and send it out to you by the tomorrow morning. And that we'll talk about your final exam.
Okay.
All right? Because this was an awesome conversation that we had. And so this was an important class for me to do. Yes, and it was important that I talked about the negative boy. If you're asking, well, you wasted time talking about this dude. No. That's an important part about it.
That story is never going to die because people are going to have to keep learning this equation.
All right, Sophia, I apologize. I'm going to check out my Canvas email in my inbox. I will make sure to answer all of your questions about the final exam. The reason why I kind of gave it to you guys a little bit not half finished, but just like I didn't have time to make a video is because I did want you guys to see it. I don't want you guys freaking out about it. I want you guys to have it in your hands already. Done. Deal. Good. We cool? All right. I'll talk to you later. I got to start class now for chemistry. Hasta mañana. Or hasta, what is Wednesday?
I should know. I took that class.